Hi everyone, I'm Phúc from National Institute of Informatics, Japan. I'm gonna present MTab, an automatic tool for tabular data annotations. This is a collaboration work with Ikuya Yamada, Natowuki Kekaton, Ritaro Ichise, and Hideki Takeda. MTab is a tabular data annotation tool. You can get many useful information about table structures, like location of table headers, subject columns, or how to interpret table data with semantic annotation using knowledge graphs like cell annotation with entity, column annotation with types, and column pairs annotation with properties. Semantic annotation also are the SemTab challenge tasks. In this work, we focus on usability of the annotation system. So we designed the MTab tool to work with multilingual tables and could be able to process many input table formats such as CSV, DSV, Excel, Markdown table format, or table content text. MTab also provide other structural information like table headers, subject column location. Users do not need to do many intensive setup or configuration, so they can get the annotation result using MTab APIs or visualize the annotations with the graphical interface. So MTab will be updated with a new DOM of Wikidata, Wikipedia, and DBpedia. This is the MTab framework. First, we build Wikigraph from DBpedia, Wikidata, and Wikipedia. The graph is integrated from the DOMs of the three sources. Currently, the login time around 2 months. Given a table in the format of text, file object, or table object, MTab first perform pre-processing phase with the table encoding prediction and then cells normalization. I mean, like we removed HTML text, cleaning text, or remove some of noisy text. The next phase is structural annotation, in which the system predict the data types of each table cell and table column. Either they are named entities, objects, literal object, or empty objects. And then the MTab perform header detection using heuristic rules. Table header could located in some of the first rows and have the data types differ from the motor data type of the data rows. Table header text usually shorter or longer than the data row text. Then MTab system perform subject column prediction based on the uniqueness of the cell values in the columns. So the next phase is the semantic annotation. If the inputs do not have the annotation targets, MTab tool automatically predicts the annotation targets based on the cell data types and column data types. The CEA targets are the name entity cell, CTA targets are the name entity columns, and CPA target are the pair between subject columns and other columns. Then we perform semantic annotation on the targets. The system perform entity candidate generation. With entity search modules, we provide a tree search module, keyword search with BM25 algorithm, fuzzy search with edit distance, and aggregation search, what is the wave fusion between keyword search and fuzzy search results. The default search of MTab tools is aggregation search because give the best performance in our tests. Finally, in post-processing, we perform value-based matching to calculate the context similarities between entity candidate statements in the subject column with the table rows values. Finally, we generate the annotation for CEA, CTA, and CPA based on majority voting of context similarities. Basically, these steps are similar to our last system, MTab for Wikidata. So this is our results on hard table and bio table. route to this year challenge. For hard table, we got the first rank for the 3 tasks, CEA, CTA, and CPA. For bio tables, we got the second rank on CEA task and the first rank for CTA and CPA tasks. So in this slide, I'm going to introduce the demonstration of an MTab tool, how you can do the table annotation using our interface. You can try MTab at this link. We do not keep your data. All of your data is completely deleted after the annotation processes. This is one example of table annotation using MTab tool. The left image is an input table in text format. It's copied from table files. Table cells are expressed in Japanese, and users do not need to provide annotation targets. The right image is the annotation results. Table header is in the first row. Subject column is in the first column. This table cells is annotated with an entity, like here it is the Tobu Chiki Hospital. And this columns is annotated with the hospital types. And the relation between subject column and other column, for example, this columns is annotated with the postal codes property. Entity search is another feature of MTab tool. User could search relevant information, relevant entity by its label. The tool supports multilingual text and could handle noisy text such as abbreviation, OCR errors, encoding problems, and misspellings. In this example of misspelling of a store name, basically it is really hard to find the relevant entity using standard entity search of Wikidata, DPpedia, or Google search. But you can find relevant entity with MTab tool because we have a fuzzy search with edit distance. And in this mode, we use aggregation search. So overall, in this work, we focus on usabilities and how to do the table annotation in real-world setting. We introduce MTab tool with public APIs interface, and users do not need to do many intensive setup or configuration. They can get the annotation result really fast, around 2 seconds for one table, and it's really effective. In this year challenge, we got a promising performance in round 2 datasets, and in the last 2 years, MTab was the best performance system. So in the future, we will provide long-term support for MTab tool. We will update the database with a new DOM of Wikidata, DPpedia, and Wikipedia. So if you have any question or feature request, please feel free to open the issue on our GitHub project page here. Thank you very much.